Hello there and welcome to Module 4 Quick Review. So we went through 4 topics in Module 4. So it's time to spend just a few minutes wrapping it up, reviewing the whole piece and reviewing the most important pieces from Module 4. So let's do that. Again, our focus in Module 4 was to look at specification-based testing. Our view always remains to build high quality product. Validate the functions with respect to specifications, and of course, we would want a lot of defects to be uncovered. For us, we have not kept any limitations of what applications we look at. We are looking at plethora of them. Our focus being software test methodologies, we have looked at all kinds of applications. So some of the examples that you still need to keep in mind when you're learning these is going to be some of these applications, or automated teller machine or a coffee vending machine. These are very good examples, day-to-day examples, which allow you to learn the systems while not looking at very complicated systems. Very complicated systems have its own complications and may lead to digression from our focus of software testing. So as we look at those methodologies, we came up with a method. In fact, we looked at category partitioning method. And what we wanted to do was to apply certain process and steps in a very systematic manner to come up with test cases. And that is what we did. Now, while the text recommends this for certain methods, I in fact go ahead and recommend this for overall testing. Whatever you do, follow that methodology, which is an 8-step systematic method for generation of test cases. And of course, here is where you look at how it is a mix of manual and automated steps. So as you go ahead and look at the requirement specifications, so if I look at requirements analysis, convert this requirement analysis into all that we need from a spec perspective. So it could be test spec or it could be design spec. All of this becomes useful when we look at a method which we follow from its steps. Here it's an 8-step method. It can lead to automated and manual tests. In addition, the steps themselves can be automated. So thus, you get 2 parts to it. One is a systematic method. We look at automated and manual test cases that come out of it, and as well as the steps themselves could be automated. That brings in tremendous amount of productivity and efficiency. So let's quickly look at what were those. We start looking at analyzing the specifications. We look at identifying the categories, the inputs that we look at. We make those choices. And if you recollect, we also looked at that diagram from the text, which you can refer to. We put in constraints in place. Thus, we have input. We analyze it. We look at what are the categorizations. We look at valid, invalid subdomains. We look at how the entire input can be partitioned. We look at constraints and then move on to our next step from 5 through 8, which are actually to do with generation of test cases. Most of the steps lead to a very good outcome from a high quality testing perspective. Here, this gives tremendous amount of method, a systematic way where all inputs, its environment, constraints, all of that taken into account lead to certain choices that one makes from a testing perspective. In addition to this, if there is domain knowledge, which is the target domain in which the product is going to be released, which could be telecommunications, medical electronics, healthcare, web-based systems for weather reporting, fleet management. If target domain expertise is available during these steps, that can add a lot of value in terms of generating very good, high quality test cases. We applied these and this method not only to equivalence class, but we looked at combinatorial and decision table. Many systems allow for a lot of inputs. They may or may not be digital alone, but they may carry multiple values, and combinations of values would make a lot of sense. So in those cases, we look for all kinds of combinations. And combinations can be based on various factors, various levels. And typically, we would want all of this to come in where we are looking at very high reliability. And of course, we looked at examples related to interoperability as well, where we have got, say, multiple browsers on multiple platforms working with major websites. This combinatorial in itself is a technique, and combinatorial opens up possibilities of testing, say, interoperability, specs. One of the examples that we stated was the MMS, various clients and servers that connect with it. The combinatorial piece expects us to model the input and in fact look at all the factors. As the number of variables and their values become larger, the number of combination itself can become astronomical. In that case, the breaking down of the system into subsystems, making things subsystem oriented or even smaller than that, will provide a lot of manageable sets, smaller sets than what the whole thing could be. That is what we could imagine, and then bring the number lower, where each combination forms one good test case. Maybe in fact there would be multiple test cases per combination, but at least there is one minimum per combination. And let's look at it, how it works in the decision table space. Now, before we move there, we would want to look at how these inputs, unique combinations, would make sense. Now, as they become astronomical, huge, we also would want to consider certain reduction methodologies. So we would want to reduce the number of test cases. Of course, reduce the number of test cases not randomly, but we would want to make sure that it does not hamper the quality of the product that is being tested. And testing is one of the mechanisms to declare a product a high quality product, where we are looking at pairwise testing or orthogonal array or design of experiments. Now, having said that, there'll always be a lot of end result that we are expecting. That's the exit criteria. Now, without such an exit criteria, it may not be possible for us to really call a particular testing done. And then models come up. Here is where we look at a fault model. Two or more variables play a role, or probably there are certain values that play a role. And then we moved on to look at decision tables. Decision tables for us bring in that logical rigor. So we bring in and in fact enforce the logical rigor. One of the graphical methods is the cause-effect graphing. Flowchart or cause-effect graphing is no longer the in thing. However, during conversations, during design discussions, cause-effect graphing can be very, very effective. And this entire method put in a tabular form, which itself is the basis of this method, it provides a very systematic mechanism where we start looking at conditions. We build conditions which can either be true or false. They could be don't care. And then we build actions based on each of the presence, absence of a particular condition or it being true or false. Thus, we come up with rules. Here we have listed 8 rules because there are 3 conditions. That is the 2n rules. Now you can imagine that as this set grows, you're going to have the number of rules increase. One of the ways that reduction can happen is when you're looking at don't cares. The moment there is a don't care, you would see rules collapsing. Now, don't care is not the mechanism of collapsing the rules. However, you could have smaller decision tables. So entire set of say 50 inputs could be divided into smaller set of decision tables, which makes sense. That's again breaking down the problem. And then looking at those test results to build up confidence in the entire system. So that's one technique, very, very powerful technique. In fact, we will look at this technique from state-based testing perspective. We'll look at system testing perspective, and also even representation and design of the system. Because this is one of the very rigorous mechanisms even to specify the system. So thus, by now, we have a set of techniques at our disposal and in our arsenal for us to take on the system testing world. And the three that we looked at in module 4 was domain partitioning, combinatorial, and decision table. And prior to this, you've already looked at equivalence class and boundary value analysis. These combined together is how one should solve the problem. And that is where we looked at a system, a fleet management system. And in fact, I would want to go back to the slide and see that each of these, we have an email client or we have a mobile phone. We may want to look at a combination of these techniques to come up with test cases. So even if while learning, we have a focus. Our focus is one technique, one example. In reality, you would always find that we would look at combinations. Thus, with this, module 4 would allow you to solve certain problems, day-to-day products that we use. We've got a TV remote, a web-based shopping cart logic, where you're shopping by value or shopping by weight. Or problems which are involving insurance renewal premiums. Again, most of these problems, in fact, 4 problems that we looked at were very clearly decision orientation, and a tabular mechanism like decision tables would definitely help us solve this problem from a design perspective as well as from a test perspective. Again, this was the interoperability view that we looked at, and we extended this further in this particular assignment where we look at not only the desktop but also the mobile phones. Thus, you can imagine browsers. So we have browser B1, B2, B3. This on platforms like Windows, Linux, and then mobile phone platforms, which are 3 of them, 1, 2, and 3. All of these form combinations. So we would have combinations where we have 3 mobile phone platforms, 3 browsers, 2 desktop platforms, and 3 browsers. So this starts becoming really huge when numbers increase, but a combinatorial mechanism helps us. And if you look at design of experiments or orthogonal arrays, you could still reduce it based on the focus that we have. So last but not the least, we had this particular example, a school attendance system, wherein if you look at only one technique, it would be very difficult to solve this problem. But now, with all the set of techniques that we have, it would be nice to solve such a problem. So I hope you will be able to attempt this problem and solve it for a design of test cases, a set of test cases. And if we treat this as a subsystem in the entire school's management system, then you would know that this, what we are treating as a system itself, may be a subsystem into a larger one. And this concept later is going to extend into system of systems for us, which you would look at in further modules. So I hope you enjoyed the specification-based testing part 2, and that brings us to the closure of module 4. Thank you.